Okay, so we're going to look at the exponent and log functions. This is the beginning of our first unit. To start with, we're actually going to review some exponent rules. So you would have saw a lot of these exponent rules in Math 9 and then probably again in Math 10. So to start with, we have the product rule. When you multiply two exponents with the same bases, you add. And actually, you know what? I'll just get you to look through these exponent rules. In Math 10, you probably would have looked at these two, which is negative exponents and fractional exponents. We'll be using all of these exponent rules in these questions. So let's just start off here. So it says write each expression without brackets and with positive exponents. So my first step is I'm actually going to multiply the coefficients. So 4 times 2 is 8. Now I'm multiplying two exponents with the same base. So I have x to the third and x to the negative fourth. So when we multiply two exponents with the same base, we add the exponents. 3 plus negative 4 is negative 1. Now we're going to do the same with the y variables. So if you don't see an exponent, you should always assume it's 1. So I have y to the 1 plus y to the 2, which gives me y to the 3. When we're simplifying, we're not going to leave the negative exponent there. So what we're going to do is we're actually going to bring that x to the denominator. So then our final answer is 8y to the power of 3 over x. Now we've talked about this before, but the best indicator that separates the best students in Math 30-1 and the okay students are kids that check their work. So if you want to double check and make sure that you did this right, substitute a variable in for x, such as 3, any number, in for your variables. Maybe you make y 4. Type in the original equation, type in the simplified equation. They should give you the exact same decimal value if you did it right. So this is a super simple way to double check your work and make sure you are doing the questions correctly. So if you want to be the type of student that separates yourself from the pack and you want to excel in this course, you have to be willing to double check your work. Okay, let's move to the next question. So this question, notice how that 3 on the outside, that exponent, it applies to the entire base. Okay, so not just to one variable, it also applies to that coefficient 3. So that means I have 3 to the power of 3, which is 27. And now, because I have an exponent raised to another exponent, I'm going to go ahead and multiply them. 2 times 3 is 6. And then for the y variable, 3 times 3 is 9. All right, and we're all finished there. Okay, so now we're moving to the next question. When we divide, we will first of all start by dividing the coefficients. 24 divided by negative 4 is negative 6. But when I divide, I end up subtracting the exponents. So for my m variable, I have 5 minus 4, which is 1. You can put the 1 there, but you don't need the 1 there. Negative 3 minus 2 is negative 5. 4 minus negative 2, watch out for that double negative. So 4 minus negative 2 is actually positive 6. Okay, so that's my first step, is I'm just applying those exponent rules. Now I'm going to take anything with a negative exponent and move it to my denominator. So that p to the 5th is going to move to the denominator. There we go, and that's my final answer. All right, next question. So again, that negative 3 is applying to the entire base here. So 4 to the power of negative 3 is, if you type that in your calculator, it should be 1 over 64. X to the power of negative 3 is x to the negative third. Negative 2 times negative 3 is positive 6. Okay, so again, we're multiplying those exponents. All right, so now when we finish off here, and you can kind of put the 64 in front, or I'm putting it in the denominator here. So then the x to the third would go on the denominator because it's a negative exponent. The y to the 6 would stay in the numerator because it's a positive. And I actually don't need the 1 there, so I'm just going to replace it with the y to the 6. All right, there we go. So there is an exponent puzzle that I handed out in class, lots of great review questions. So if you weren't here, you didn't get a chance to try it, ask, and I can let you take a copy home. So now it says rewrite each expression as a base with a power of 3. So what we're going to do is we're going to replace this 9 with 3 to the power of 2. Okay, and then it's still raised to the power of 2. So really I have 2 times 2 because I'm raising the exponent by this exponent. So 2 times 2 is 4. So I end up with 3 to the power of 4. Again, super easy to double check. Try typing 9 squared on your calculator, then try typing 3 to the exponent of 4 on your calculator. It should give you the exact same value. Okay, so we're going to do the same thing here, except for we have a bit more difficult of a question. So 27 is the same as 3 to the power of 3 raised to the 1/3. 81 is the same as 3 to the power of 4. And then I'm going to write this radical as a fractional exponent. So the 2 would be the numerator in my fractional exponent. And remember, when you're writing your fractional exponent, the index of the radical is always the denominator in your fractional exponent. So my index is 3, meaning my denominator would be 3. So now I have 3 times 1/3 is just 1, right? Those 3's cancel out. And I'm going to put the 1 there. 4 times 2 over 3 is 8 over 3. Okay, so now we're not quite finished. Our last step, when we multiply 2 exponents with the same base, we add the exponents. So you can type this in your calculator. You don't need to do it off by heart. 1 plus 8 over 3 is 11 over 3. And now we're finished. Once again, I would take the time to double check my work. Try typing the original equation, type the new one. They should match if you did it correctly. Okay, let's try a couple more. So we're going to convert 125 to the exponent of 2 minus x to a base of 5. So I know 125 is the same as 3 to the exponent of, or 5 to the exponent of 3. Okay, and I'm going to put that 2 minus x. So when we multiply, we're really distributing that 3. So 3 times 2 when I distribute is 6. 3 times negative x when I distribute is negative 3x. Okay, 512. You know, I might actually have to use my calculator on this one. So because it's a denominator, right away I know it's going to be a negative exponent there. So I have 512 is the same as 2 to the power of, let's try 8. 2 to the power, oh, that didn't work. Let's try 9. 2 to the power of 9. So I know 2 to the power of 9 is the same as 512. Okay. So that means that I'm going to replace that 512 with 1 over 2 to the power of 9, just like that. There we go. So I replaced the 512 with 2 to the power of 9, or exponent of 9. Now I can just multiply those exponents. So 9 times 3x is 27x. Okay, and you could leave it like that. You should realize it's the same as if I were to write this. Right, those would be the exact same thing. Okay. Simplify the following and write with positive exponents. So we're going to simplify this. There's different ways you can do this, but I'm going to solve by raising to the opposite power here. So to cancel out that exponent. So negative 4 over 3, if I were to raise that to the power of negative 3 over 4, that would cancel out, right? Because negative 4 over 3 times the negative reciprocal would just equal 1. But if I do that to the left side, I also need to do it to the right side. So on my calculator, I'm just going to type 81 to the power of negative 3 over 4. And then I'll use my math fraction. I end up with 1 over 27. So again, what we did there is we raised by the negative reciprocal. And the reason we did that was so that it would cancel out and give us an exponent of 1. And if we do that to the left side, we also need to do the same on the right. So here again, I'm going to raise this by the reciprocal. I don't need the negative reciprocal this time because I have a positive exponent. So the reciprocal of 2 over 3 is 2, or 3 over 2 is 2 over 3. If I do that to the left side, I need to do it to the right. So now I end up with 27 to the power of 2 over 3 gives me 9. And from here I can solve for x. So I'm going to go ahead and add that 5 over and I get 14, and then I'll divide the 3 and I end up with 14 over 3. Again, just to kind of show you, if you want to double check this, because I like to double check every single question in my work, that's how I know if I'm doing it right. We have two sides of an equation. So on your graphing calculator, and I'm not going to do this in this video because it would take too much time, take one side of the original equation, type it into y1. Take the other side of the original equation, type it into y2. Find the intersection point. That intersection point will be your solution, which should match the answer we have here. All right, that's it. These are great questions to practice, and just really make sure that you know those exponent laws. It's going to be hard for you to move forward in the unit if you don't know those exponent laws like the back of your hand. So make sure you have a really good grasp on them.